In the space of science and colossal inclination toward pieces of information, the subject of what existed right off the bat to the monstrous impact has blended conversations and enraptured characters for quite a while. This Goliath request doesn't just test how we could unwind the universe, it challenges the genuine farthest targets of human data. Envision standing at the edge of existence, investigating the vast shadowing, and considering what lay there before our universe was imagined. The event of the Big Bang signified the beginning of history, space, and what we know. Anyway, there was a moment sooner, early this May. There, in the end, may have been a condition of nothingness, a calm before the fuming gathering began. And if this is true, was it? Or perhaps there was something generally more disturbing that existed before time itself. As we jump further into this question, science takes us on a trip past the universe's beginning stage into considerations that challenge our attention. Physicist Brian Cox, known for his focus on the miracles of the universe, proposes that something dazzling might have existed before the Big Bang. He moves us to reconsider our thinking of the authentic world and presence. In this evaluation, we'll explore the science, the speculation, and the astounding insider mysteries that could sort out what existed prior to all that. We'll investigate assessments like unwavering improvement, quantum changes, dark energy, and, surprisingly, the multiverse. The answers we've uncovered might just cover you, but they could yet also open new understandings of our circumstance in the universe. Plan to plunge deep into a world beyond imagination science, where the dim still winds around the shadows, leaving specialists shocked and sometimes even steamed. We should break down what existed before the Big Bang and why these theories challenge everything we expected we knew. To appreciate what could have existed before the Big Bang, we first need to look at what the Big Bang actually was. The Big Bang, as theorists depict it, was the event when the universe ended up being strikingly hot and dense, expanding rapidly to set off the creation of all matter, energy, and limitless powers. When we look toward the night sky, we see proof of this hot beginning, with systems spreading out from a starting point. Anyway, what made this happen? Was there a time before this thick, hot start? As shown by the theory of cosmic inflation, there was indeed a before, and it was far from void or quiet. Vast inflation proposes that, prior to the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a motivating vacuum. Anyway, the vacuum wasn't absolutely unfilled. It contained a gigantic amount of energy that controlled the quick increase of space itself. This advancement, called inflation, happened so rapidly that it essentially set the stage for everything that would happen in the fraction of a second. Space stretched out at incredible rates until the development slowed down, and the energy transformed into matter particles and the forces we think about in the Big Bang. But what was the nature of this energy? Why did it, from nowhere, support the universe, and why did it stop? Analysts believe that this boundless inflation created patches of the universe, each experiencing its own Big Bang. Imagine a surface expanding endlessly with small fuel bubbles forming, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially unimaginable Big Bangs and a limitless number of universes. Our own is only one of many. This colossal, staggering reality challenges how we could interpret the very universe itself and leaves us with a question. What else is out there? The possibility of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Whether or not you remove all energy, particles, and radiation from the universe, it would still not be truly void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that we have yet to fully grasp. Even in its most empty form, the universe still holds something. Whether we imagine stripping away these forces, leaving a dead space, the universe would still generate new kinds of energy. This truth is perplexing to researchers, as it suggests that genuine nothingness might be impossible within our current understanding of space. Space itself has properties, rules, and constants that prevent it from being absolutely unfilled. Imagine creating a region with literally nothing in it. No particles, no radiation, no negative energy, except for quantum fields and fundamental constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a theory called zero-point energy, which refers to the lowest possible energy state of quantum fields. In this state, particles can still appear and scatter, creating a disturbing echo of change, even in what should be void space. This challenges our idea of a true void and suggests that even before the Big Bang, there was something. Researchers are still evaluating this. One of the most astonishing theories in modern cosmology is the possibility of eternal expansion. If inflation could create our universe, it's conceivable it could continue indefinitely. Brian Cox describes an incredibly vast inflationary multiverse, where universes are spontaneously created and evolve. Imagine each Big Bang as a flash lighting another universe, while inflation happens in different regions, creating countless other universes. This process could theoretically happen forever. This idea of titanic universes creating others leads to a fascinating concept of a fractal universe, where each new universe may, in fact, create its own Big Bang. Each universe exists as an independent space, unaffected by the others. For scientists, this hypothesis is both exciting and disturbing, as it proposes a perpetual multiverse with no clear beginning or end. Imagine our universe as just a spot in a giant cosmic plan, constantly creating and continually making new universes. What if that's the true essence of reality? There is no before or after, but perhaps an eternal pattern of universes forming. How we interpret nothingness changes when we think about the infinite cycle of creation. If the multiverse hypothesis is true, we might be witnessing only a tiny fragment of a much larger, unending cosmic structure. The notion that universes could continuously form and evolve without a distinct starting point or end forces us to rethink our understanding of time, space, and existence itself. Every new Big Bang could give rise to its own set of universes, each unfolding independently from the others, creating a reality that stretches beyond our current perception of the cosmos. This idea challenges our very understanding of creation. If the multiverse is indeed infinite, it also suggests that our universe might not be as unique as we once thought. Instead of being a one-time event, the Big Bang might be just one of many such events, happening in different regions of space-time, perhaps even in parallel with other universes. This could mean that there are countless other realms, each with its own laws of physics, its own history, and its own form of existence. The implications of this are profound. It suggests that the universe we know may not be the only one, nor is it necessarily the most important. It opens up possibilities that stretch far beyond our imagination, possibilities that challenge the boundaries of science and philosophy alike. If the multiverse is real, then we are part of something far larger and more complex than we could ever fully comprehend. As we delve deeper into these ideas, we begin to encounter questions that may never have definitive answers. What does it mean for something to exist in a multiverse? How do we understand identity and reality in a setting where infinite possibilities are constantly unfolding? And most intriguingly, if we are part of a vast multiverse, what role do we play in the grand, seemingly infinite scheme of things? For now, these questions remain speculative, but the pursuit of answers continues. As science progresses, we may one day find ways to test these theories, perhaps uncovering evidence of other universes, or at least gaining a deeper understanding of the forces at play in the cosmos. Until then, the question of what existed before the Big Bang, if anything, remains one of the most profound mysteries, inviting us to look beyond our familiar world and contemplate a reality far more expansive than we can imagine. Consider the quantum field hypothesis. As shown by this hypothesis, the universe isn't just a mix of issues drifting in space. Perhaps it's a convoluted relationship of energy handles that fill the universe, associating with cause all that we notice. These fields resemble irrelevant seas, with particles going about as waves or aggravations. In any event, when fields are basically energy at a level known as the vacuum state, they are still dynamic. Particles can appear and disperse in these fields, immediately getting energy before returning it. This trademark leads to virtual particles, substances that quickly exist and then dissipate, leaving only a weak memory of their presence. The possibility of virtual particles challenges the validity of a certified void. Imagine an unfilled universe where all matter, radiation, and energy are disposed of. Would you have, truthfully, nothing? As per the quantum field hypothesis, you wouldn't. Even in a vacuum, fields would stay dynamic, sometimes making transient particles. This reliable movement in the thing ought to not be anything suggests that the universe doesn't adjust to our concept of void. The fields and powers keep filling the universe with private energy that forestalls absolute nothingness. This brings up a dazzling issue. If fields make particles and particles make matter, might the genuine universe at any point have risen out of this nothingness, loaded up with quantum fields? Dark energy is an odd power that currently drives the accelerated expansion of our universe. In any case, did dark energy exist before the Big Bang? As per a few viewpoints, the way that dark energy exists today suggests that a beast, puzzling power might have existed in some form before the Big Bang. A few speculations propose that dark energy, in a much stronger state, might have controlled the inflationary stage, causing rapid development. The presence of dark energy suggests that, whether our universe was purged of all matter and radiation, this power would continue to develop the outer layer of spacetime. This thought prompts an upsetting inquiry. If dark energy was present before the Big Bang, might it at some point have eventually formed the circumstances that led to the birth of our universe? Might dark energy at any point be the quiet architect of expansion or even the genuine start of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe, but as a key that could unlock the mysteries of the multiverse itself. Another speculation is that cyclic cosmology offers an option in contrast to the Big Bang as a conclusive beginning. This hypothesis suggests that the universe goes through immense cycles of birth, death, and restoration. In this model, the Big Bang is not a one-time event, but rather part of an undying cycle, where universes form independently and then revive in another cycle. This hypothesis proposes that our universe might have been re-established from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would imply that there was never a genuine beginning but rather a timeless series of universes arising and renewing themselves over and over. Cyclic cosmology raises critical questions. Never a better time than now, as it suggests that time itself could repeat rather than continue. If this theory is correct, it could imply that what existed before the Big Bang was essentially another form of the universe, one that collapsed solely to give birth to our current universe. For scientists, this hypothesis offers a rich answer to the question of extreme beginnings, suggesting that there is no clear beginning, and the universe has always existed in some form, transcending our concepts of time and existence. Gravitational waves are another captivating concept that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are ripples in spacetime caused by incredibly massive objects like black holes or colliding neutron stars. These waves can travel vast distances, carrying information about the events that created them. Could gravitational waves offer insight into the creation of the universe? A few physicists suggest that gravitational waves from the time before the Big Bang could provide clues about the state of the universe before inflation began. Gravitational waves from the early universe might leave traces that could help us understand whether the Big Bang was truly the beginning, or whether there were vast events before that we don't yet appreciate. These waves could be remnants left by events beyond our standard understanding, and their presence could also suggest a greater structure beyond the one we are currently aware of. These faint signals could open insights that could alter our perspective. Just as we uncovered the Big Bang's origin, consider how plausible it is that they show the faint traces of a past universe or an event that happened before the Big Bang. As scientists continue to explore the deep realms of space, the question remains: what existed before the Big Bang? With current theories highlighting quantum mechanics, multiverses, and cosmic expansion, it seems we are closer than ever to unraveling the profound mysteries of the universe's origins. While the full answer remains elusive, our understanding of what existed before the Big Bang continues to evolve with every discovery. As we explore these theories, we can also consider how they might fit together to reveal the larger picture, the true essence of existence itself. But until then, we are left with a mystery driving science and venturing into dark spots far beyond what we have yet realized. We continue to dig into the secrets of what existed before the Big Bang. Clearly, how we understand the universe is constantly evolving. One critical area of examination involves the connection between existence itself and time, as we experience it. Time might not have existed in the way we understand it before the Big Bang. Some theories suggest that time as a concept began with a Big Bang, making it difficult to trace what preceded it. This idea challenges our fundamental impression of existence, suggesting that the question of before may not truly be relevant when it comes to the universe's origins. Furthermore, later advances in the study of quantum mechanics have sparked revolutionary ideas about the nature of reality. One particularly fascinating concept is the possibility of a quantum vacuum, a state where, even without any matter, the universe isn't truly empty. Rather, it is filled with fluctuating energy handles that can give rise to particles and forces. These quantum fluctuations might have played a crucial role in the development of the universe, as they would have provided the necessary conditions for the Big Bang to occur. This raises the question of whether the universe could have emerged from a quantum change, or if it was somehow triggered by these fluctuations. Another intriguing aspect of pre-theory regarding the universe's origin revolves around the concept of cosmic recycling. In cyclic cosmology, the universe undergoes an endless series of expansions and contractions. After each Big Bang, the universe would eventually contract back into a singularity before expanding again. This repetitive cycle could mean that the current state of the universe is merely the latest version in an eternal series of cosmic births and deaths. Some scientists suggest that each cycle could lead to slightly different outcomes, with the current structure of the universe shaped by the conditions of the previous cycle. This idea challenges the notion of a definitive beginning, suggesting instead that the universe is in a constant state of renewal. The possibility of extra dimensions also adds another layer of complexity to how we might interpret what occurred before the Big Bang. String theory, for example, proposes the existence of additional dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These extra dimensions could provide an entirely new framework for understanding the universe's beginnings.